Alright, so this lesson is just an extension of the one you did last night, the little short 8-minute video, and this one's going to be just about as short, at least for me, and you guys are going to have just about the same amount of writing that you had last night. So yesterday we talked about when there are parallel lines and they're intersected by a transversal, what do we know about the angles? We know that the alternate interior and the alternate exterior and the corresponding are congruent, and we know that the same side interior and same side exterior are supplementary. So that was all about what we know about the angles. What we're going to do today is we're going to be proving that lines are parallel. So remember yesterday we had a picture and the lines were already parallel, and then we knew stuff about the angles because the lines were parallel. Well, today we're going to do very similar. Instead of drawing parallel lines like I've been doing, I'm just going to freehand draw all these lines to kind of make the point. So here is a line, and here is another line. Now, when I drew those lines, would you absolutely bet for sure that they are parallel to each other? Hopefully you wouldn't, because I just kind of freehand drew them, right? You don't know that maybe if we could extend our computer screen this way, for 100 miles, maybe eventually these two lines would cross, right? Or maybe if we could extend it this way, these two lines might cross. So I can't say that these lines are parallel because I just, you know, basically ripped my pen across the paper and made a line. But I can say that they're cut by this transversal, right? And you see it's not very straight, it's not very good at all. So I have no way of knowing if this transversal is actually intersecting parallel lines or if it's just intersecting two random lines. So I'm going to label all my angles again. So 1, 2, 3, 4, 5, 6, 7, 8. So I want to think for a minute about what would have to be true for line L and line K to be parallel to each other. Well, you just learned all these theorems yesterday, right? You learned that if alternate exterior angles, so 1 and 8, if 1 and 8 were congruent to each other, wouldn't that mean that these lines were parallel? Okay, I'm going to write down a statement from yesterday. I'm going to write the corresponding angles postulate. Okay, so as we get more comfortable with these, we can start to abbreviate more. And it said if two parallel lines are cut by a transversal, then corresponding angles are congruent, right? That's what we wrote yesterday. So let's look back. Let's look at what I'm trying to get you to do here. I don't know that these lines are parallel, right? But what if I knew that angle 1 and angle 5 were congruent? Would that mean that these lines are parallel? Okay, hopefully you make that connection and see that it would mean that. But that's not what this says. This says if two parallel lines are cut by a transversal, right, then corresponding angles are congruent. Okay, what can we come up with that basically says this, but says it backwards, right? I want to say if corresponding angles are congruent, then the lines cut by the transversal are parallel. I want to say it backwards. What's that called? That would be the converse of the corresponding angles postulate. Remember, a converse is when we exchange the hypothesis and the conclusion. So I'm going to write down the converse of the corresponding angles postulate. And remember, when you're talking about the hypothesis and the conclusion, the hypothesis here is that the lines are parallel. That's my P. And the fact that the lines are congruent, or the angles are congruent, that's my Q. Now all the words that fill in here make it readable and make it make sense, but really all we're saying here for the corresponding angles postulate is that P implies Q. So our converse needs to say Q implies P. So I'm going to write it. I'm going to write if corresponding angles are congruent, then what? Remember, the parallel is my big idea, right? Transversal, nobody cares about that. It's just a line drawn through a couple other lines. So it's not a big deal. The parallel is the big deal. That's what people care about. So if corresponding angles are congruent, then lines cut by a transversal are parallel. Okay, and the reason that it's important here, the reason that this matters, is the corresponding angles postulate, this one right here, tells us about the angles. The converse tells us about the lines, right? So when we do our proofs, if part of our proof is to say that angles are congruent, it's going to be because of the corresponding angles postulate. But if our proof gives us some corresponding angles and we want to say, well, that means the lines are parallel, then that reason in the proof is going to be the converse of the corresponding angles postulate. And you guys, just like yesterday, now you're going to have the converse of the alternate interior angles theorem. You're going to have the converse of the alternate exterior angles theorem. You're going to have converse of the same side interior angles theorem. It's okay to abbreviate that, right? You're not going to think I mean the stainless steel internet angles theorem, right? Same side interior. And we have the converse of the same side exterior angles theorem. And one nice thing about all of these is all of them are going to prove lines are parallel, right? So for the rest of your notes, you're going to write down each one of these, write them down, write down their conditional, the if and then part that goes with them, and for each one of them, we want to say that line L is parallel to line K based on the converse of the corresponding angles postulate, or the converse of this, any of these converses. And we're going to need to be able to talk about them in class tomorrow. That's it.